Good morning. We're going to go ahead and get started on today's webinar, and just for the essence of time, we will start this recording and start the webinar. So again, thank you for everybody taking the time this morning to attend today's Trimble Dimensions 2012 Highlights webinar. Now, just a couple of notes here on housekeeping and how we are going to conduct the webinar today, as well as some notes in regards to what we're going to do for today's webinar and the purpose. So first of all, the purpose of today's webinar is just to bring some of the Trimble Dimensions highlights on the survey side to everybody and to allow you to get some of the conference highlights from Trimble Dimensions, especially if you weren't able to attend. Obviously, most all of you were not. We can bring some of those things to you in a short little webinar. It's a 3-day conference, so we're going to try to condense some of the survey highlights into 90 minutes. So it's going to be a little bit fast and furious. We are going to record the webinar and certainly make ourselves available after the webinar for questions and things like that. So if you do have questions, I would just ask if you could try to hold them till the end of the webinar, and we'll open it up. Otherwise, if you do have an immediate question, certainly use the chat window in the GoToWebinar utility and submit a question, and we'll try to answer it the best we can as we go along. But just for the sake of time and to run through this, we're going to try to limit those to the end of the session. We also want to get your feedback. So at the end of this session, if you can meet up or talk to in the near future one of your Frontier representatives and just let them know how it went, what you thought of it, and if it was something that was worthwhile. This is something we want to find out if people want to attend in the future, if this is something we want to do on an annual basis, or at least after every Dimensions, which is pretty much a 18-month, 24-month event. If this is something that you would like to see again, just let us know. We'd appreciate that as well. Lastly, I just want to introduce a couple of people that are going to be helping me out. My name is Steve Richter with Frontier Precision. I'm also going to have Jay Haskamp do some presentation here this morning. He is one of our Trimble certified trainers and support personnel, as well as Allison Walls is on the call today, and she's also one of our trainers and support personnel to help us today with the webinar. All right, let's go ahead and get started. So as you can see, some of the conference highlights from the 2012 conference in November. Trimble did introduce a new Google SketchUp, which we'll discuss in brief detail. And they also introduced a Bentley strategic partnership. Those details are pretty vague at this point, so we don't have any specifics on what that partnership is going to do for us or mean for us. But we are looking for some big things in 2013 from that joint partnership between Trimble and Bentley. We'll also talk about the expansion of the RTX satellite coverage and what that does and what that means for you. That is not a misprint. That is RTX. It is not RTK. It is an RTX satellite coverage. So most of you are probably not familiar with what that is, so we'll cover that in a little bit here in the session. Some of you have probably heard about the new Trimble R10. We'll talk about that briefly, as well as the new Trimble TX5 laser scanner. And then lastly, Trimble TBC, latest version 2.81, and then the latest version, Trimble Access 2012.2. Okay. So to start, we're going to talk about what's new in Trimble Access. And here's just a quick little synopsis of what we have going on, what we're going to talk about, what versions of Access started in 2011 with the TSC3 introduction, all the way through 2012.2, which was released October of 2012 with the introduction of the Trimble R10. I'm going to go through a lot of these enhancements from that point in time all the way up to today. So with the TSC3 introduction of Trimble Access, obviously a lot of you have been introduced to this. This particular controller allows you to take pictures, link those pictures with Trimble Access, do some geotagging with those internal GPS that's internal with the TSC3. using the compass for stakeout, internal 3G modem, as well as different keyboards. I always want to just cover the image capture because it's, again, a very powerful tool, and it's not being used with Trimble Access probably as much as it can be. There's a couple of ways to do this, and I just want to cover a couple for you just as a review. Make sure that you're aware that the controller or the camera with an iFi Wi-Fi card can be used. So if you have an older TSE2, you can even use a camera that supports Wi-Fi or iFi and link them that way. Or with the TSE3, just use the embedded image capture on the TSE3 to do image capture with your features and attributes. So if you are doing image capture, you'll notice in your properties of current job of Trimble Access, you can set the media file on how you want that media file to work. Whether you want it to be from the previous point, whether you want to link based on a point number that you choose or the next point, or just an image file for the job, that's available to you as a configuration setting within the Trimble Access software. If you are going to use a feature like, let's say for instance, the most common one would be next point, you'll notice in this particular image we're taking an image of some kind of utility box, and we're linking it to the next point. We're telling the software we want to show the media file before we store the point, and we also want to geotag at the same time so it puts our GPS position on the image. So to do that, it's basically a quick three-step process. We would basically start the camera application on the controller by hitting the function and 1 key, FN1. That supplies a shortcut right to the camera application. We use one of the enter keys that you can see highlighted here in red to take an image or accept that image. And then we just hit the OK key once the image has been captured. We hit that twice to store that image, and now we can choose to do what we want to do with it, much like you saw on the previous screen where we can geotag. We can attach it to a feature based on the setting we have in Trimble Access, whether it's the next available point that we take or the previous point that was shot. And if we geotag, you can see you can put some XF data, embedded text, or both with that image as well. So a couple of things about how these images are stored. As described in the previous slide, you can see the controller can embed the controller position onto that image. However, if you're using Trimble Access and not the embedded geotag function in Windows, you can embed the measured position that was measured with your GPS to that particular image using the geotag function setting within Trimble Access. So as a review on that, the TSE3 that many people are now running with Trimble Access, you can use that for geotagging, which we already talked about. Obviously, you can use the internal GPS for navigating, and then also if you're using a robotic total station, the integrated GPS search within Trimble Access can be used with the TSE3. Also, with the introduction of Trimble Access with the TSE3, they introduced this compass. So keep in mind, if you're using a TSE3 with Trimble Access, you can turn on the compass. You'll notice in the upper left window that the compass has been enabled. You can see the north arrow has got a couple of dashes around it to indicate to the user that the north arrow is being generated and displayed using the compass embedded in Trimble Access software. And the picture on the right, the compass has been disabled. The north arrow is just a standard north arrow. And you can see here on this screen, you can configure that under the Options key in the stakeout menu. All right, so in May 2011, there were some enhancements to Trimble Access. They called that Trimble Access 2011.00. I'm just going to talk about a couple because, again, these were discussed in great detail at Trimble Dimensions, as well as something that we don't talk about a lot through our support channel. So I just want to make sure everybody is aware of these things that are available in 2011 Access. 2011 Access supported the new BMP or bitmap JPEG images. They can be georeferenced images with the associated world files. You can upload basically those as background maps and use those in Trimble Access. Jay will be showing here a little bit later how to export a JPEG georeference image right from TBC using the image and capture image function within TBC. The nice part about that is it makes those files a lot smaller. However, you do need an advanced version of Trimble Business Center to use that function. Here's just an image or a picture of a georeferenced image. You can see a point number satellite icon right on the display. It makes it much more convenient. It brings things to light a lot easier. You can see where things are falling on your georeference map as you do your survey. Also in 2011, they supported the shapefile import as a background map with hatching, so you can see a picture of that here. Also was supported in 2011, you can lock down a survey style. We don't have a lot of people using this, but it is a nice function. Locking down your survey style will make sure that field crews don't edit them, change some of the settings, things like that. Notice that starting a survey with a new lockdown survey style applies all the updates with respect to any antenna or receiver settings that may have changed as well. And you can see in this screen snap what it would look like if you had a lockdown survey style. You get a little lock in front of it there. Icon updates. You'll notice when you go to 2011 Trimble Access, some of the icons will have changed, will have appeared changed. Note that some of these icons will appear to be the same no matter what receiver, radio, or prism you're using. They're very generic to the system, but the icons are different. So here's a screen snap of what some of those icons may look like. So you can see the total station icon looks much like a Trimble S6. The prism icon looks like a Trimble 360 prism, and that holds true throughout, no matter what prism you're using. They have different different symbols below the prism for what you're seeing at prism number 1, if it's locked, if you need to add a prism, so on and so forth. Down below you can see if you're using GPS search, the prism and GPS satellite icon, I guess you'd call it, in the lower left. And then you can see the new receiver, GPS receiver and satellite icons there on the right. The Trimble radio icon has also changed, as you can see in the lower right. Okay, and then in September 2011, Trimble introduced Trimble Access 2011.1. So with that update, they introduced the land seismic option. Most people aren't using this SDK option, but it is an option here. I just wanted to bring up a slide on what it does. Basically, this particular land seismic option allows you to work in a seismic grid stakeout routine. It works within the Trimble Access jobs. It uses the same jobs, but it also allows you to bring in other jobs from GPS seismic software for grid-based navigation, for exclusion zones, for calculating offsets with these TPL files. So GP Seismic Office has a direct integration with land seismics. So if you're doing any seismic work, that integration is built into Trimble Access with this module. And notice a note here that this land seismic module is an excellent example of how the Trimble SDK works. Certainly look for more SDKs to be introduced in 2013. There will be one introduced from Frontier Precision in January of 2013 on land surveying geodetic module that you'll see here in the next 30 days or so. Okay, moving on to 2012, or this past year, Trimble introduced Access version 2012.1. Some of those enhancements were pretty I would say pretty major. Panorama was added to the Trimble Vision instruments, so the panorama feature that you have for the Trimble VX was also added for the Trimble S6 with Vision. You'll notice you have this new volumes and surfaces tool. You have the integrated interrupted target measurement, which I'll also talk about, the OmniStar, as well as how some of the stakeout display orientations are changed. The reason I'm going into a couple of these, like stakeout display and volumes is these are things that a lot of you that have attended our user group meetings in the past have asked for. And I just want to make sure that you realize that some of these things that you've been asking for are now coming to fruition. And in Trimble Access 2012.1, you can do some of those things. Now, before I continue, there is one question that did pop up here in the chat window that I want to cover. It was from the previous slide, so before I get too far away from what we're doing here, the question was, what is SDK? And I'm sorry I didn't cover that. Trimble Access SDK stands for basically a software development kit. So if you have the Trimble Access software development kit, you could create your own module to do some of the things that you want it to do, the software that is, specific to your needs. So for instance, there are other modules like that I will cover in short detail. Roads is considered a module. There's a mining module. There's a monitoring module, and there are others. These are very specific modules that are embedded with Trimble Access to allow you to do very specific functions that you want to do. So if you have some ideas for SDK, we are an SDK user of Trimble's. We do software development on Trimble Access. Let us know if you have a specific application, and we can talk to you about how that could be integrated with Trimble Access. And the last major improvement for 2012 Trimble Access.1 is how the Trimble Access Installation Manager, or TAME, is used with old versions and new versions and back and forth, and I'll cover that in a little bit. All right, so you notice that under the instrument menu of the Trimble Access software, when you're connected to an S6 total station that has vision, that it has the panorama function there towards the bottom. Now you'll notice that this is available on the new Trimble S6 Vision instruments. It's not on the VX spatial station, so it's a little bit tricky there. Just make sure you're aware of that, and you can see it's found under the instrument menu. It's called Panorama. What Panorama allows us to do is it allows us to basically take a panorama image rather than just a single image view from our S6 total station. Oops, sorry, one too fast. The next thing that was introduced that I had up there as a bullet point is the surfaces and volumes within Trimble Access. So you'll notice now you can create a surface and compute a volume right on board your TSC3 controller, including a TSC2 controller if you have Trimble Access 2012.1. This is a huge improvement, something that we've been asking for quite some time. It was introduced earlier in the Trimble tablet. Now it's on board the controllers that you use every day in the field. I think this is a big thing, so I am going to show you a couple of screen snaps and what some of this may look like. Notice in this particular screen snap that we've gone into the map screen and we've selected a series of points. We've tapped and hold on our map screen to bring up the menu. Once those points have been selected, you'll notice compute volume is one of those options. So if we choose compute volume, it's going to ask us for a surface first and a surface name. So we go ahead and give it a surface name. Then the select volume method box comes up and it asks us how we want to compute this volume. So if we're going to do two surfaces, maybe a boundary surface and then an entire surface, we might choose the surface to surface method, which would be the most common. We can also choose these others like above an elevation or a stockpile depression type of surface. Once we choose our method, we tell it, in this particular case, the void volume they're choosing. We tell it the elevation and whatever shrinkage that we have, depending on the material that's in this particular volume. And we compute that, and you can see the computation is stored right here. We can record that. There's also a report that you can generate or right out of Trimble Access as well. And then lastly, you can store that computation so that you can review it later if need be and return back to the map display. When you return back to the map display, you can optionally, this is an option, this is not something you have to do, but you can optionally display that volume in color gradient, as you see here, with lowest number of 99 meters being in blue and the highest number being 123 meters in this brighter red color. So you can kind of see where your depression is. You can also display triangles as an option if you wish, or you can display both. So you can display color gradient and triangles. So that is a huge improvement, a nice part of the software that was added to Trimble Access 2012.1. Okay, moving on, interrupted target measurements. So another function here that was added is the use of interrupted target measurements if a measurement is likely to be interrupted. So for example, if you're taking some measurements with your robotic total station or autolock total station across a very busy road, things like that. So notice some of the points here. The autolock measurements do not stop if that target is obstructed. You can start the autolock with an obstructed target, and then during the automated measurement, the instrument fails within that timeout period that you set. The instrument will turn back to the target and attempt to reacquire. This is supported during some kind of station setup, resection, or when you're using also the measuring rounds routine. Note that this is something that is within the Trimble Access software. However, the Trimble Access also works with the Trimble Total Station at a specific firmware to make this work, and that firmware is noted here below. So if you have an S6, S8, or VX Total Station and you want to use this function with your Trimble Access, you have to have a release version 12.3.39 in your Total Station or later to use that function. Okay. A new enhancement to the QC graph. You can now display points with numeric attributes. So that's something that they added in that version. Another coordinate system that was added is called the snake grid coordinate system. Basically, it's a minimal scale factor with height distortion for projects that are very, very corridor based or elongated. So example, rail project, something that will be straight or a snake type of pattern. It's a customized parameter file for each project location alignment. So there is a website that they note down here at the bottom on how these particular coordinate systems work. Personally, I've not done much with this at all, so this is a very new technique. It's not something that's been employed in too many scenarios. Okay, some other additional improvements worth noting here. You can now specify a start station for an alignment defined from the map screen if you key in the alignment, or if you want to just go stake out and choose the alignment routine. Previously, the start station always defaulted to 0. So as an example, if you upload an alignment or DXF file from your CAD software and you choose to stake that out as alignment, even though you may have defined a starting station on that DXF alignment, it would always start at 0 in previous versions of Access. In 2012.1, they've changed that where you can actually define that start station to match what it would be if it was in your CAD software. This was one of the requests that we've gotten from a lot of people that are doing stakeout and using the alignment routine. Being able to define that starting station of the alignment is very important to them. So this is a very key improvement in my mind. Also note in Trimble Access Installation Manager, when you're going to version 2012.1, you can now select a version of Access installed. So if you have a series of controllers that are all in the same version, however one controller has the ability to be upgraded to the latest version, you can keep that controller on the old version so that they all match if need be, using the select version dialog box that you see here in the screen snap. Just be careful when installing older versions of Trimble Access. You need to uninstall the current version first. There is a website there that explains how to do that. You can't downgrade a job, so if you have a job in the new version of Trimble Access and you decide to go back to a previous version of Access, those jobs cannot be downgraded back to the previous version. So this is something that Trimble has allowed people to do, but it's definitely something that you only want to do when need be. It's not something that we would recommend in too many scenarios. All right, and just a note on a couple of these specialized applications. This goes back to this SDK application that we talked about previously with land seismic. You can note that these are all SDKs, roads, tunnels, mines, the land seismic application SDK that we talked about before, and Access Sync. And at the end of today's presentation, Jay is going to give you a demonstration on Access Sync and talk about what the new Access Sync promotion is available to anybody running Trimble Access that has a current warranty certificate or a current on their license of software. So most of you know what Roads is, especially if you're using Survey Controller. Before you used Access, Roads was a part of Survey Controller. It's now a module of Trimble Access. I just want to cover in the next couple of slides what has changed recently in Trimble Access Roads that you may not be aware of. First thing is spirals have been renamed to transitions. So it's no longer called spirals when you're keying in a road. It's now called a transition. Okay. Trimble Roads, some of the improvements here is switching between the plan and cross-section views. And it's selectable delta display options now for plan and cross-section views, as well as the display area is larger for these views. And you'll see a couple of other things here coming up as well. So a calculated construction offset now can be applied when you stake a Trimble road by station offset. Previously, this option was only available when you're staking nearest offset, which a lot of people did not use. So now you can use a calculated construction offset. Basically, this means you don't have to change the earlier defined construction offset if you encounter some kind of obstruction and need to move, your offset based on that obstruction. Anybody that's using Genio Roads, one thing that they did change here is the graphical stakeout selection improvement for the GPS position is now displayed there, so you can see that as you're staking a Genio road. And then also if you're staking a Genio road in a conventional survey, the instrument position, backsite, and instrument are now displayed. Construction offsets for the 5D string now appear as well in the stakeout plan and cross-section views. Here's a big one for Trimble Roads now when you're using, this is a 2012.1 of Trimble Access. Now when you're using the a template, you're keying in a template, you want to use that in another road possibly. You can now copy that template from one road to another so you don't have to duplicate that process. This is a huge improvement, something we've had customers asking for a little while. Again, based on what I've seen customers looking for, this is a very big key feature with Trimble Access. Staking position from a file enables staking from a CSV file now relative to a road. So if you have a CSV file that has basically your stationing, your offset, elevation code, as you see there with the the 10+00, the 7-foot offset, and the 25.29-foot elevation, and shoulder is your code. If you have that particular CSV, you can actually load that in the controller now and allow you to stake out your position on the road with that CSV file. So that's a new feature as well. And then cubic and blast spirals are supported in this version of Trimble Access. All right, moving on to tunnels. What are tunnels? Again, it's a specialized Trimble SDK application featuring an auto scanning feature with a total station and the ability to identify under and over breaks. So you can see here in this image, you got a graphical interface, a cross-section auto scanning routine with tunneling, a measurement process to ensure station surveying with irregular surfaces, as well as bolt hole set out and custom reporting for the tunnel application. Another SDK is the mining SDK, which allows for, it's more of an underground, by the way, mining feature, not an above ground mining feature. Just to streamline your workflow for a drill rig type of development for your drive set out. Allows you to easily select matching pairs of points for your laser lines, your pivot positions, and your blast holes, as well as automated stakeout for center line, grade, and laser lines. And lastly, you can stake out the blast hole colors and your drig rill pivot positions for these underground applications. Another SDK is monitoring. We've talked about this a little bit with our customers, and some of them are actually using this monitoring application. It's just, again, streamlining the from a regular survey into more of a monitoring survey. And some of you actually probably use your regular general survey for some type of monitoring. Well, this actually contains a different file, this mjob, and this MOBS file, this observation file, which contains station setup, backside information, and then all your measured observations for more of an automatic or manual pointing type of monitoring. It'll allow you to see alerts if you're out of tolerance, rather than you take it back to the office and find out later that this monitoring setup was out of tolerance. You can find out right there while you're on the site. And you can do a tolerance test. And then as well, you can get this custom report, which allows you to see graphical scatter plots and any tolerance data regards to the monitoring prisms or GPS positions that you're measuring. Okay, so let's bring it up to date. This is Trimble Access 2012.2. Really, there's not a lot of changes to Trimble Access 2012.2 except for this new Access Sync, which I said Jay is going to cover in a demonstration. I will talk about it briefly, but he'll cover more in a demonstration here in a little bit, as well as the new Trimble R10, which is the new GNSS receiver from Trimble that I want to cover what Trimble Access is doing to support this particular receiver. And it looks a lot different than a traditional GNSS receiver. As you can see here, the size of it is much smaller. The shape is much different. It has a battery door on the side rather than underneath, so you can see some differences just ergonomically. But inside there are some key, I guess they call them key features, that you should be aware of that are going to be kind of revolutionary in regards to the RTK technology. First one is called HG, High Definition GNSS. I'll talk about that. The next one is going to be called SurePoint, and then they have this new thing called Xfill, Trimble 360, OmniStar, and Wi-Fi. So here's a quick look of the R10. You can see it's got a small keypad, small antenna. Radio antenna comes down just like it does in the R series receivers, R8, R6s. It's got a SIM card slot under the protective battery cover, as well as a battery, 2 LEMO ports, 1 for USB connections, so you can actually connect and take files to and from, if you're collecting raw GPS files, to and from the receiver on a jump drive, as well as an integrated quick release adapter. So let me briefly cover what some of these features are. HD GNSS is the next generation processing technology. Basically, it's now precision-based measurements. What I'm referring to here is there's no fixed or float technique with this receiver. So as you're aware with your Trimble R8, R6, your Trimble 5800, the system goes from float to fixed, and then your precisions come into a certain tolerance and you can measure and store points. The R10 does not work that way. The R10 does not have a fixed float scheme. It basically is a precision-based measurement. So what you see is what you get based on precisions. The advantage of that is basically starting to be able to measure sooner. You don't have to wait from a float to a fixed to happen. Your occupation times are shorter, and the confidence in measuring is much higher, especially in the environment that this particular image is taken in the woods there. So precision estimates and their associated tolerances are now the sole indicator for your point measurements. Okay, there's no fixed, there's no float. So it's a little bit different in that regard. You'll notice on your screen of your display, you'll get a green tick mark to determine or tell you if it's within the tolerance that you set as a user. it really simplifies how the system works in that regard. A note, by the way, you see at the bottom of this screen, older receivers still use a fixed float mode. Okay, R10 is the only one that does this. So this is what you would see if you're using an R series receiver, R4, R6, R8, 5800. You see a fixed indicator, a precision horizontally and vertically, and RMS. This is what you're going to see with an R10. So in this particular case, you're going to see if it's in differential, if the RTK is not initialized, and then you're going to see a precision-based measurement if it's outside of tolerance, and then you're going to see a precision-based measurement if it's inside of tolerance, either with a X, meaning you're outside, or a checkbox, green checkbox, saying you're within the tolerance that you set. You can start measuring. Another technology is the SurePoint, which allows you to use the tilt sensors on the R10. Okay, those tilt sensors essentially give you measurement automation, increased accuracy with tilt warnings, and a tilt distance that you can review. You can actually map, you can report it in TBC, you can even graph it in the QC graph, which is pretty cool. And then lastly, this cool little electronic bubble. So I'll show you that as well. The electronic bubble is called the E-bubble, of course. Enables clear, easier, more accessible measurement views in regards to your leveling and measuring, or leveling during measuring. Coupled with the tilt auto measure, the E-bubble allows you to measure points automatically when the pole is within a tolerance, and I'll show you a little video of that. And you can see from this image, this is what the electronic bubble would look like. You can see it any time on the TSC3 with the Control L key when using an R10. That'll allow you to show or hide the E-bubble for any screen that you're in. You don't even have to be in a measuring screen. You can see it anywhere. So topo and rapid point measurement support this E-bubble, and it's configurable how well or if you want the tilt auto measure to be used, and also the tolerance. Let's go back to that screen here. And you'll notice here a little video on the bottom. It's just going to show you how that tilt auto bubble kind of works. So you can see that here. So as I level up, it goes green. As I go out of level, it goes red. And I'll show you a little video of that here in a second. But here's just the, I'll just leave this screen up here for a second or two just to show you this is how it works, basically how to configure it, how to start it. You basically plumb the pole using the E-bubble. The auto measure starts when the pole is plumb and stable, and the point is stored after 2 epochs have been completed, and you walk to the next point. The pole gets plumbed up again and it starts to measure again. You don't have to hit any button on the screen. All you're doing is looking at your level bubble, which is what a surveyor should be doing. Okay, so you can see that you're going to get some status indicators there. It's waiting for you to move to the next point. It's waiting for you to level now that you're at the next point, and now it's measuring. So let's go ahead and take a peek at how that works. Hopefully everybody can see this video okay. You'll notice here's your E-bubble down there. All right, so you can set the tilt tolerance on that E-bubble for topo and rapid points, as you can see here. And you can see as you set the tolerance tighter and tighter, the black ring circle will be tighter and tighter around that green bubble. If you're going to do an e-bubble, well, first of all, I should say the e-bubble needs to be calibrated from time to time. And if you are going to be using the e-bubble, you'll notice that the e-bubble works with the data collector when the receiver's keypad is pointed towards the same way that the controller is facing, much that you see in this particular image here. So if you're using the e-bubble, you need to have your receiver pointed in this particular orientation. And like I said, the e-bubble needs to be calibrated from time to time, and you can do that within the Trimble Access menu. I'll show you a little video of that as well. All right, so you can see here that the e-bubble, I'm going to go ahead and pause this for a moment. If you notice down here, this is your actual bubble on your rod or your tri-brac or whatever you're using. Notice that that is plumb and your electronic bubble is not. So it's a good indicator to you that this needs to be calibrated. So the rest of this video is going to go ahead and show you how to how quick this calibration process is and how easy it is. So what you're going to do is you're going to go ahead and you're going to align the instrument receiver keypad with the data collector, much that you see in that picture. You're going to go to the instrument menu by going ahead and tapping and hold on the receiver icon. If you release after tapping and hold, you'll see an e-bubble soft key. You can go into the soft key and notice there are a couple of things here that you can modify. Maybe I'll back this up briefly. Oh, too fast. You can see you can modify the sensitivity, the tolerance, the e-bubble configuration here for medium, low, or high. And then you can calibrate, and the calibration is just going to tell you that it's going to calibrate the tilt sensors within the R10. Make sure the instrument is level and braced, much like you see here with a bipod. Tap OK when you're ready to calibrate. So once you tap OK, the calibration process will start, and I'll let it run. You'll see it'll be 10 seconds or so. It's very, very fast. And you can also have a warning. You can see a calibration age limit of 30 days. You can have a warning to tell you, hey, every 30 days, recalibrate your e-bubble. Now you'll notice it's calibrated. It matches your pole calibration. You're ready to go do your survey. These tilt warnings are displayed. Note if the pole is outside of a tilt tolerance. In other words, the bubble is red and outside the circle. When starting a measurement, you'll see a tilt warning, that kind of thing. Also, when you try to store and it's outside the tolerance, it's going to tell you tilt warning. You want to accept or remeasure. A couple more things that I'm going to discuss, and I'll turn it over to Jay. Trimble Xfill, that is the new RTX, not RTK, but RTX technology that Trimble has introduced in their ag division about a year ago. It's been brought into the R10. Basically, it allows you to continue surveying when you're interrupted by your RTK-based radio or your VRS network is being interrupted. All right. Notice when that interruption happens, you'll get an Xfill indicator on the display, and the Xfill coverage is dependent on satellite positions of that RTX satellite system, making sure that you're within those boundaries, and I'll show you those boundaries in a moment, as well as the position quality is reliant on the true WGS84 positions of the base. So in essence, you want your base to not be in a here position when you're using Xfill. Not recommended. You also want to make sure if you're using VRS that you have good VRS base positions. So typically in a VRS scenario it would work very, very well as when you're setting your base on a known point. So in essence, when you lose connection from your base station because radio went down because you went over a hill or behind a building, so on and so forth, Xfill will kick in and basically provide you with centimeter level accuracy during that downtime for a short period of time. That short period of time happens to be about 5 minutes. You'll notice that the solution will diverge over time. So every minute that you have lost radio link or your cellular signal and you're using Xfill, you will incur another centimeter of error horizontally and 2 centimeters of error vertically. So still very, very tight, very, very accurate without a correction, which allows you to get more work done and be more sufficient in your surveys. Here's the current exfil coverage. You'll notice all of us in the U.S. are covered. If you happen to do some work overseas or anything like that, but you'll notice if you're up in Alaska, exfil is not available at this time. There's also a Wi-Fi setting in the R10, which is supported with Trimble Access to allow you to work in an access point or client mode. Making sure that the Wi-Fi is off in the R10 if you're not using it. You can't use Wi-Fi to connect the controller to the receiver or anything like that. Wi-Fi is typically used in an R10 to configure the R10 wirelessly for outputting, say, an NMEA message, or to set up a fast static measurement without a controller or something like that. Okay. And then the RTX is basically a function of this OmniStar system, and the OmniStar is supported in the R10. It is not supported in the R8 or the R6, and that is a subscription-based service that allows you to get higher accuracy, not RTK accuracy, but higher accuracy measurements with your receiver without a reference station. One of the other changes is with the R10 and Trimble Access 2012.2, you do not need to drop all satellite signals by dumping the antenna anymore. There is this new reset satellite tracking function within the system, and the system will drop the satellites and reacquire lock automatically for you. The QC graph has changed. You'll notice now because of the R10 and the tilt measurement that you can store from the eBubble, you are actually allowed to QC graph your tilt measurements. You can also define the y-axis range so that if you have some measurements that you know are way out, maybe you have zero elevations or something like that, you can tighten up that y-axis range to not even display those points, or they don't display the same. And here's a QC graph of the tilt distance. You'll notice all these tilts are within 4 centimeters, and you'll see one that probably was purposely measured that way so that they can show that you can see points that are outside of tolerance. One other thing in 2012.2, when you're staking out, fine and coarse mode are gone. You won't see that anymore. There's no soft key anymore. The receivers are now set to operate in low latency mode at all times when you're staking out. Also, when you're doing total station offset measurements, you can set a default offset. In previous versions of Access, there was no default. You can set a default offset so that it can be picked from a menu. If you're doing 5-foot offsets all the time, or in this case 35-meter offsets all the time, it allows you to store a default offset for angle and distance measurements. You'll notice in 2012.2 you have the graphical stakeout screen, which allows you to display a grid. So in this particular view, there's no grid. You'll notice that there are 2 grids available. There is a, well, there's your no grid, by the way. There's your 2-meter or 9-foot grid, that you see. And as you get closer to your point, there's your basically 1-foot grid. So it just helps you graphically say, hey, I know I need to move north 800ths, or I should say south 800ths in this case. It's just a lot easier without having to look to the right here and look at your distances and add them up. You can see on the grid, find stakeout points a lot faster. You can reverse the line and arc direction in Trimble Access 2012.2. And when staking a line or arc, you can use the station plus or station minus, and you'll notice that in previous versions, if you had a line defined, it would actually take you beyond the line. It would never stop at the end. Now you have the option to stake the end point of the line, which is something that a lot of you have been asking for. And that's in 2012.2. So you can stake out the end of the line. It'll actually stop you there. And here's an example, a quick example of that. So now you're selecting your 2 points and keying in a line. Sorry, the graphic will catch up. It's a little slow. And you can see your line has been defined and stored. Now you can escape back out to the map screen, and you can select your line. right-click or tap and hold, I should say. You can reverse the line. You can also offset the line. Okay, so those are some new functions. Notice now when you go ahead and define your station interval to stake the line, as you're staking the line, you can bump the station up. When it gets to the end of the line, as you'll notice here in a moment, it will ask you, hey, I'm at the end of the line. Do you want to stake out the end point of that line? Previous versions would have just kept going. So that is a new function, Trimble Access 2012.2. Okay. New laser lock function allows you to use the laser pointer in the dark to find your prisms a little easier. And a couple other minor improvements are averaging duplicate points are now supported with weighted and unweighted. So now you can duplicate points as a weighted solution or unweighted solution. The laser rangefinder, Laser Ace 1000 is supported now, and these PNG type of image files are now available as a background map. Exports for DXF are in every version of Trimble Access 2012.2 as well. And then we did talk about the R10 improvements that we just discussed. So before I turn it over to Jay, are there any questions regards to Trimble Access 2012 or the Trimble R10 support in Trimble Access?